Hi guys, and welcome to the next session on common probability distribution. Now, if you were obviously learning in a sequence, you might have realized that I've actually skipped the topic or the reading on probability directly because what I've seen naturally is in all of these CFA classes, the direct probability reading tends to, bog down a lot of people because it's a little confusing and in the process what happens is you actually skip probably losing your entire motivation to complete quant, right? So the interesting part is actually after that second difficult reading, which is on probability directly, which we can actually cover it later because the main concepts which get actually used in finance finally starts from here, right? So what we're going to do is we're going to first complete all the rest of the readings in quant and then come back to a simple reading on probability, right? So let's talk about common probability distribution. So you can see that of course we're talking about still probability, but then we're talking about distributions as well, right? Because you have to understand that when we're talking about finance specifically, right, we are dealing with data which is in the form of returns, right? Or sometimes we might be looking at stock prices, right, which are not obviously in percentage but in absolute prices, and we're looking at time data. Right now, if you realize in all of these cases, there is a very less chance that these will be absolute values, right? Because even if you say that return in 2012 was 5%, usually this is not true because it will be 5.21256%. And even in stock prices, you can't really say that the stock price is exactly the same in both the days, which means that we are not looking at discrete data. We are looking at continuous data, right? So we are looking at continuous kind of data, right? Which means that you can only understand them statistically uh, in a distribution format rather than talking about a specific price, right? You could talk about saying that there's a 60% chance that the stock returns will be between 6% and 12%. So we can talk in range, right? Now, since we can only talk in range, which means that we need to understand the range itself. The range is again in the statistical format, you would call it as distribution, right? So, if you remember a little bit on the last class that we discussed, we had a normal distribution, right? So that is how a distribution would look like. So you're basically trying to understand, okay, what is the probability of things happening at this range, right? So that's the reason why we are discussing, distributions at the first place. And second is that yes, we will also touch upon other kinds of distributions that are existent, which might sound a little boring, but it does get interesting after a couple of slides. So let's get started. So again, plenty of LOSs. I think it's a pretty large and a long reading, but we're gonna take it in parts, so don't worry. So as was touching upon the fact that finally probability calculations, or you making a statement on a certain data, finally depends upon what the data type is, right? Let's say if you're talking about number of years. Now, number of years obviously will have specific values, right? So 1, 2, 3. So you could call this as discrete, right? We've already spoken about in the first chapter itself, right, that there is something called as discrete data. So the value can only be 1, 2, or 3. Generally you will not speak in terms of 1.2341 years, right? So other aspect, which is investment value, right, can be continuous. For example, there can be n number of points of returns between 3% and 4%, because the value could be 3.01%, then the value could be 3.0112%. So since there is no particular order, or you can't really say a pinpoint at a particular point, you would call this data as continuous, right? So that's the basic on where it gets started. Right now let's look at the nifty 50 distribution, right? So I had shown this you I had shown you this in the visualization of the data itself. Now if you see the distribution of nifty 50 obviously is not exactly normal because there is nothing called as an exact or a perfect normal distribution, but you can clearly see that yes, this is a form of continuous data, right? In terms of the returns. So these are just the plot of returns, the number of values or count which is happening between a certain range. So if you looked at this specific point in the middle, right, which is 1%, you are meaning to say that there are about 3,000, let's say about 800 instances of returns being in this range, right? Uh, which is something called as, which is continuous data, right? So continuous data can be presented in this way. Compare this with a distribution, number of positive or negative. So we are saying that, okay, I don't want to know, what the exact returns are, but just tell me whether was it positive or whether it was negative. So then you just have two values which a data point can take, which means that this is nothing but discrete data, right? So same nifty 50 returns, we've tried to find out how many positives or negatives are there. It just means discrete data, right? Now let's look at what is called as the PDF. Now we've slightly covered this, but what does this mean? It just means probability, okay, probability density function. It might sound a little complicated and out of the box, but all that it means is that, as I said, we want to make a statement for a specific range, right? So the first question out here is, what is the probability that we will see returns less than 0% daily for Nifty 50? Remember, the data out here which I've plotted is a daily return data, right? So once you've plotted this, in terms of either this chart or maybe, in terms of a frequency table, right? Uh, what you would try to do is, whatever the bin frequency is there, so you could see that anything below 0% is all the way from here. Okay, so we are interested in whether the returns will be less than 0%, right? So if you see, your 0% is somewhere around from here up till here, right? And if you might remember from the first class on the visualization of data, in which we were talking about a histogram, uh, this is the frequency, right? These are the number of occurrences. So in order to get a relative frequency, what we used to do is to divide this by the total number of observation, right? And if you divide it by this n, you tend to get the relative frequency, right? And if you were to convert that relative frequency into, let's say, a cumulative function, right, stating that, okay, if this is 0%, this is actually not zero. For example, out here there's one occurrence, but since we are dealing with only one decimal places, this looks like 0%. But let's say even if it is 0, right, and let's say these values are very minuscule, if you just keep on adding these values up till the point of 0, then you would come up to and say that, okay, the frequency, the cumulative frequency, relative frequency is about 17.74, which is what I have calculated, right? So that is nothing but PDF, right? Now in terms of a chart, this would look something like this. Okay, so for example, this was the normal distribution that we had plotted, and let's say this was 0. Okay, so all the occurrences below 0% would be in this shaded area, right? So this would be the area where this is actually happening. And when I say 17%, then I mean to say this. So that would be the PDF. Okay, someone, if you would have said that, okay, how many returns, how many what is the occurrence possible till 1%, so then you would shift till here, right? And then you can see in terms of the relative frequency table that that's about 63%. Then you would say that this entire thing on the left hand side would be 63%. right? So that's nothing but the PDF, right? The probability density function, which is a term used for all kinds of distribution, not just continuous. Okay, now let's go to the uniform discrete distribution. Okay, now uh, what I always recommend people is to just look at the terms, and sometimes it's the gist of the concept, you tend to get it there, right? So you're saying first of all it's uniform and it's discrete, as opposed to the previous distribution where we said it's continuous. This is not continuous, it's saying uniform, right? And it's discrete, that means there are only certain values a certain frequency can take, or a certain event can take, right? Think of examples which probably are uniform and discrete, right? So you could talk about of rolling a die, right? A die, if you are rolling a dice, and there are 1 2 3 4 5 and 6 values that you can see in all the sections of the dice, right? So if you ask me what is the occurrence, so first of all, looking at the fact that this is discrete, because it can only take specific value. When you roll a die, you can't really have 5.5, so that means that proves this point of a discrete distribution, first of all, right? Second is uniform. What does uniform mean? We are saying that at every point of rolling a die, the probability of each of these values happening is same, which is nothing but 1 over 6, right? Because there are 6 possible outcomes, and the probability of any each one of them happening, right, is just one occurrences, right? So at a point in time, there is only a 0.16 percent probability of any of these outcomes happening when we first roll a die, right? So that's what is denoted by the px, the blue one. The blue graphs that you see is nothing but denoting the probability of each of these outcomes happening. But let's say I limit it. Okay, let's say I limit the amount of times we roll the die. Okay, as opposed to saying that we're just rolling once, I'm saying that we will roll the die 6 times. So there is a finite time, uh, how many times I'm actually rolling the die, right? So let's say we first roll the die. So the probability of, let's say, getting a 1, okay, is, let's say, about 0.167, right? Now you are asking the next question, right? Rolling a second die, what is the probability? 0.16, okay. But what if we change the question and say, what would be the probability that we could have a value less than 4 in 4 die rolls? So we are talking about until here, okay. So what is the probability that we could get a value less than 4? Which means out here, right? So not greater than 4 but less than 4, right? So all you need to do is just cumulate, and you, if you think intuitively also, it makes sense, right? Because since each of these outcomes has a 16.6% probability, right? And considering that we've rolled a die, and the initially the probability of having, let's say, 4 was 16%. It did not come, we rolled the die again. Now let's say the 4 did not come again, so your probability of expecting to get 4 increases significantly in the next period, the third period, the fourth period, and finally in the fourth period you can see that the cumulative density function says that, okay, there's a 67% probability, right, that the fourth outcome can be a 4 value, right? So that's nothing but a uniform discrete distribution, right? If you think about this practically, I don't see this being used immensely in finance, but yes, understanding that such a distribution exists is important. Okay, now look at uniform discrete distribution. Again, we're just continuing with the same explanation, right? So how would you find the probability that the value will be between 5 and 3, right? So the question is, if somebody asks you what is the probability of getting values between 5 and 3 after 5 rules, right? So now the next question again, you would be interested in finding what is the probability out here in between, right? Now, let's say you were given the probability till the fifth outcome, which is 0.83, right? And you know the probability till 3 also, which is 0.5. So if you just deduct these two values, which is 0.83 minus 0.5, you tend to get 0.33, right? So what I mean to say is that after 5 rolls, the probability of seeing the value 3 or the value between 5 and 3, which is 4, is nothing but 33%, right? So that's how you tend to work on calculating a certain range in a distribution, and that is what the objective of this LOS is. Continuous uniform distribution. Okay, so again, look at this. This is uniform and discrete. Out here we've got continuous but yet still uniform, right? So when we looked at discrete, we said that the value could be either 1, 2, and specific values, right? So in case of a rolling a die, we had 6 possible outcomes, so that was discrete. Now, how can it become continuous? It can, if you were to use the rand function, the random function of creating values between, let's say 1 and let's say 0, right? If you just use Excel, then the values could be anyone, right? I mean, the values could be 0.011115, the value could be 0.111345, the value could be 2.111. So there is the nth possibility of going to the nth number of decimal places, and hence that becomes continuous uniform distribution, which means although the probability is equal, get it, but the problem is that even if the probability is equal, you can't really pinpoint at a certain value because you don't know what the value is at the first place, and hence it makes sense to talk about a distribution rather than a particular point, right? Because you wouldn't really try to find out what is the probability of finding 0.001789. Probably since the possibilities of the number of values between 0 and 1 are so much that for this value to occur, maybe the probability is just 1 over, I don't know, maybe a billion possibilities, and hence that would almost equal 0, which means that again you need to talk in terms of a range. So you might say that, okay, what is the possibility of values happening between 0 and 0.5? Then you're talking about a range in which the values can occur, right? So that's again continuous uniform distribution. Okay, so I will stop here so that you get a little bit of you at least absorb a little bit of basic distribution, and in the next video we will start with binomial distribution. As you can again make out, bi means 2, that there are only 2 possibilities. So a binomial distribution example could be even rolling or rolling of a coin, right? A flipping of a coin, because there are only 2 possibilities, heads or tail. Now binomial distribution, I'm just giving you just so that you are aware that what comes next. So binomial distributions do tend to get used in finance, especially in option pricing and even trying to predict a stock price in terms of expected value, right? So let's meet up in the next class and we will continue the discussion there, right?